Welcome to another video. This will be regarding CATIA V5, mainly the difference between part design and sheet metal design. And we're going to see why it is important to work directly within the dedicated workbench. Now, depending on the license that you have, you maybe won't have so many options within the mechanical design. So there's the part design and there is also the sheet metal design workbench. I have the parts created both in part design, which is the one on the top. If I'm gonna hide the bottom one, this is the part created for this sheet metal piece. We're gonna see that we have a pad, some pockets, and an edge fillet for the interior cutout over here. The other fillets are directly embedded within the sketch, which is visible over here. Now for the other part, we're gonna see that I colored it like this, so differently, just to better visualize that. We're gonna have the extrusion, but now for the sketch we only gonna have 3 lines. So we have a 40mm line, afterwards a vertical 50mm, and an 80 horizontal millimeter line. Afterwards you have the cutouts, and at the end we have that hem. For the cutouts, as we can see over here, I added those fillets directly within the cutout. So I could have done the same for the part design. But now, let's see the main difference. If I'm gonna display both of those, we're gonna see that the parts will be perfectly overlap. And if I will rotate around the part, we're gonna see how that shader texture will flicker on top of the model. This is because the graphic card doesn't know exactly which surface to display, since they are perfectly overlapped. So that is why when you have some flickering elements, so this is not standard only for CATIA V5, this is for anything related to computer 3D. If those will be perfectly overlapped, you're gonna have that flickering. So before we get started, maybe if you're gonna go at start mechanical design, depending on the license that you have here, in CATIA, you won't have the sheet metal design workbench over here. But this is very useful in terms of efficiency and productivity. So I also asked Bard over here. So as you can see, the sheet metal design, they had a pre-version in V4, which was released in '92. However, back then that early version was quite basic. It was only within CATIA V5, which was released in '98, where CATIA introduced this dedicated sheet metal design workbench, and they called it sheet metal design. So as you can see, this includes a number of tools like bend tools, unfold tools, and most importantly sheet metal constraints. And also there is a library for those sheet metal parts. I prefer the workbench, let's say the workflow from SolidWorks, because that library is a little bit much more customable than the one in CATIA, but you can also create in CATIA V5 custom stamps and have them added. But I like the SolidWorks workflow a little bit better. So as you can see, the sheet metal workbench has been constantly improved. We see over here with CATIA V5, which we know that now has transformed into 3D experience. So let's get back to those parts and start comparing those. So the main advantage of the sheet metal part is that if you want to change, for example, the dimensions, since the whole control sketch is only composed of 3 lines, we can rapidly, I'm just going to hide the part design to make this easy. For example, maybe I want the top part to be 50mm, not 40. I can extend that, I can leave that workbench, and we're gonna see how we're gonna have that added. So I see that it has an updated. I'm gonna go over here, update all, and now we're gonna see how that updated, and we're gonna have this extended for those 10mm. That is one advantage. the second most important advantage is regarding the sheet metal parameters. So for example, if I want to make this part thicker, I can just double click on the parameter. We see over here the thickness is currently set to 2 millimeters. That means the default band radius of 4. And let's say I want to make this 4 millimeters. I can just change this. I can update that. So currently I don't have auto update set. And as we can see, that whole part will have now a 4 millimeter thickness. So this is the main advantage. If I want to do that same change to the standard part design, I have the possibility to do that, but that requires additional work. So for example, we have this pad. Since this is part design, we need to have a close profile. As we can see, we have that close profile all the way. It was created using offset, so we can, let's say, increase that speed when we define that. But for example, I would like to have that 4 millimeter thickness as well over here. So we see this offset. I can increase it to 4 millimeters. We have it on the top. Over here, there's also an offset. I'm going to increase that to 4 millimeters as well. We're going to have another one over there underneath that constraint, so 4 millimeters. And we see that if I added this 4 over here, this sketch will no longer be properly defined. So I'm just going to delete this 6 value over there. And we have this radius, which is 4 for the interior, as we have over here. And we need to increase this to a radius of 8. Therefore, we're going to have over here that 4 millimeters. Okay, so currently I see that it's set to 6. So we have that radius. Okay, because at the top we won't have that 4 millimeters. I'm just going to add that 4 value over there. So we see how time consuming this is. Overall, we're going to have that the sketch is just not defined because I need to constrain this. So that should be 6 as well. And now I have the possibility to leave that sketch. And we're going to see the part is red. It requires an update. I can press Ctrl U to have that updated. And now I can compare that with the sheet metal part. As you can see, there are also some differences regarding the offset side where we added that material thickness. So it is really convenient to work directly with sheet metal design, where you're just gonna have a single sketch controlling everything, and after that you don't have to think about the offset value, if it should go at the top or at the bottom. As you can see, you can easily change that over here. It's much more easy and convenient. Another advantage is that we have the possibility to go over here with fold and fold, and we can do those cutouts either in the final design part like here, or we can have it folded, and afterwards we can go ahead and add additional cuts. So while this is unfolded, for example, I'm just gonna rapidly position something. I'm not gonna constrain it, and we can have a cutout for this. So as we can see, I don't have those toolbars added, but we're gonna have the cutouts over here, which will be that one. So the cutout, the handle is null in this case. Let me just reset this in order to activate all the tools, because the cutout should be with blue. So let me go to tools. We're gonna go to customize, and within the toolbar I will just restore the position of this workbench. So we're gonna have all those elements added over here. Let's see, so this is the metal design, but the cutout should be in blue. So let me see, if I'm gonna go on start mechanical design, there should be sheet metal. Okay, so there's sheet metal design and there is generative sheet metal design. And we're gonna see that within generative metal design, this cutout will be in blue. So this is the workbench, so generative sheet metal design. You're gonna have that sketch. If I'm gonna preview that, it should delete that area. And now if I will just fold it again, we're gonna see that will be added over there. There's one more thing that I want to discuss over here. We can also use this recognize feature. So for example, if I would not have access to generative sheet metal design, I have the possibility to use a standard part design using pad and other features. And as you can see, since I'm currently on this part design, I double click on that, all those other tools specific to generative sheet metal design are not active. I can only add the parameters over here, which will be added within the tree, but this button is active, which is the recognize tool. I can click on that and we're gonna see a reference face. For example, I'm gonna select this as a reference face, and afterwards, if I will do a preview, we're gonna see that in this case it says that there is a contour open. This configuration cannot be used in an extrusion operator. So let me just slightly change that back to 2 millimeters. So this should be, but the profile over here is close as well. But usually when we have this with 2 millimeters, the software is able to process that. Let's see if that will make any change. Again, recognition. I'm gonna go for this face. I'm gonna hit preview, and we see how Katia managed to recognize that. So maybe even with 4 millimeters, if I would to select this cutout, the software is able to convert that. So I'm gonna do that because I'm really curious. That was the main problem. And now we see once we have that recognized, we have the possibility to further work with features that are directly available over here. So we can add additional elements, we can create, as we can see, this wall on edge. So even though the history for this part was not created within generative sheet metal design, I have the possibility to go on a part design, have that recognized, and afterwards continue with specific features over here. For example, maybe I want this wall to be 25 millimeters, and we're gonna have that added over there. And now if I'm gonna change the parameter, maybe I wanna add 4 millimeters, we're gonna see that part will be updated. But we see that for 4 millimeters, the recognize will have an error. Therefore, I cannot go further, so over here to the wall on edge, because the error is present over there. So let me just undo that wall on edge and that recognize. And I will change that back to 4 millimeters and see if Katia will be able to use that automatic recognize. So 4 millimeters. 4 millimeters. Over here we had that radius of 8, and over here again 4 millimeters. So the thickness should be constant through all over here. As we can see, there's 4 over there. We have 4 millimeters for the radius. We have 4 over here. So the thickness is constant. Therefore, the recognize should work, because usually the recognize feature doesn't work if the part doesn't have a constant thickness. So let's try with this vertical. We see that the thickness geometry is different from the thickness defined within the sheet metal. As we can see, this part already has that. I'm gonna delete it, and we're gonna reapply the recognize with the 4 millimeters. But as you can see, a permanent recognition was encountered during this. The thickness of the part to recognize is not constant. Remove the concerned faces or normalize the thickness. Okay, so This is quite weird. We see that at the bottom we have that radius over here where Katia considers not to be randomized, and it's true because we have this R6 over here, so this should be R8, but as we can see that will no longer be the same, so we're gonna make this vertical, but therefore we're gonna have some other changes to the part. So I'm just gonna undo that. We see this is the radius that is set to 6. Let's see, the top radius will be 8, so that is correctly defined. I will try to have that deleted, and I will add a new 3-point arc over here. So let's see, from this point all the way here, this should be tangent over there, and this should have the radius 8. Over here I should add again tangency. As you can see, that tangency will make this go to the top. So let's see how we can have that changed. That radius of 4 shouldn't be a problem. This distance of 6. So we have that. Let's see. I'm gonna make this to be vertical. This as well to be vertical, so that it will no longer be changed. And we're gonna have that radius added over here. And as you can see now, the recognize feature should work even with 4 millimeters. We have that updated, recognize, preview, and we're gonna see that now we have the value added over here. So go back to the thickness of 2, have that updated, but again the recognize will struggle a bit. So I will set this to be to 4, and over here there shouldn't be any problems. Okay, so as we can see, the workflow that involves making use of part design and afterwards having that recognized is a little bit complicated, and you encounter a lot of small errors that you need to work with. And on the other side, if you are gonna model those parts directly within sheet metal design, and you're gonna decide that for some reason you're gonna change, for example, the thickness of the part, it will be much easier. So you're just gonna double click on that, and maybe I'm gonna make this 6. We're gonna see how that will update, and the part will be a lot thicker. Okay, so I hope you find this video useful. I'm gonna position a similar video to the left and a subscribe button to the right. Thanks for watching.